Marco Codes! Hi, Marco here. In this episode, we're going to continue building our command line text viewer / text editor with Java. Wow. That we started in the last episode. If you didn't see the last episode, let me show you what we did. Essentially, we started out with a plain, empty Java class, just a main method. We want to end up with something like this, where we can view text files, page through them, scroll through them, move the cursor around. And we currently have this. A skeleton for our viewer, we have a status bar at the bottom. For every empty row on the left side, we get a tilde sign, but we certainly cannot load any files. That means we also cannot scroll through them or move our cursor around. Let's change that. Oh, and by the way, if you want to follow along with me, then simply clone the repository. You'll find the URL in the video's description. Check out branch episode 1, and you have the same source code that I have. Bingo! To be eventually able to move our cursor around, we need to improve our key detection a tiny bit. Let me show you why. Back in the main method, what I want to do is I want to comment out the refresh screen method for now, which paints our editor window, the status bar and the tilde signs. Instead, I want to go down a tiny bit, and here in my handle key method, where we're handling the Q key at the moment, which simply exits the program, I want to have an else, and essentially, for every key I press, which is not Q, I want to print out the character as, well, in character form, and also the int ASCII value of the key. Now let's run this. And you've seen it before. So A, S, D, F, G, I'm pressing those keys. I get the key, including the ASCII value. Now, what happens when I press the arrow up key on my keyboard? Whoa! I'm not just getting one key or one byte sent to my program, instead I'm getting 3 of them. Now, 27, this here is the escape character again, open square brackets, 91, and an uppercase A. So in fact, when I press arrow up on my keyboard, my program gets 3 keys sent to it. Let's press arrow down. Ooh, same thing again. Escape character. Open square brackets and an uppercase B. You can do the same thing for arrow right, arrow left. Let me press page up. Whoa, page up seems to be 4 keys. So we have an escape character, we have open square brackets, we have a 5 and a tilde sign. So the problem is at the moment, our program just handles a single key press. And actually we just want to handle a single key press. I don't want to have to handle 4 different keys all the time. Instead, I want to do some sort of a virtual key mapping where when we get 4 keys, we essentially just want to have 1 key. Let's see how that works. All right, so back in our code, let's pimp our read key method a tiny bit. Because so far we've just assumed, we press the key, we want to return that pressed key to our keyboard. But as you just saw, things change once our program gets sent an escape character. So what we could do is we could say, well, if the key that the user pressed is not an escape character, right, then we're just going to return the key. Tiny quick note, Marco, you've been babbling about 033 here, but in the console we just saw 27. Why is that? Well, because 27 is the decimal representation of the octal 033. And when you want to print out an escape character in Java, you cannot just put 27 here, it will just print out the 27. So you have to go with that form, and I want to make it consistent. So up here you could have written 27 in fact, but I'm just going to make it consistent like so. Okay. So at this point, we know we just got sent an escape character, which means up next, we need to read in yet another key. So we're going to do that here, the next key. And we know, remember, the next key needs to be an open square bracket. So again, if the next key is not an open square bracket, like so, we're just going to return the next key. Right, and we're going to swallow the escape character that was pressed earlier for now. And last but not least, we now know, well, escape character, square bracket. Well, let's read in yet another key. So we're just going to go with yet another key down here, right? Here's where things get interesting. If yet another key equals, remember, uppercase A, then we in fact got an arrow up key press. If the yet another key was B, then we got an arrow down. We could actually also write a switch statement here, right? And then we have the same thing for arrow left, arrow right, and also page up, page down, home and end. These are the 6 other buttons that we want to effectively map. For now, we're just going to start with arrow up, arrow down. And what we're going to do here now is we're just going to create a new constant field down here with a high enough ASCII value that is not going to clash with our usual letters A, B, C, D, ignoring internationalization and other keyboard layouts. So we're just going to go with 1000 here. And arrow down is 1001. The specific numbers do not matter for now. Just give it 2 fixed numbers like so. And this should actually work. Let's try it out. All right, rerunning our program. ASDFG, you can see that works as expected. Arrow up 1000, arrow down 1001. Pretty cool. So what we did actually worked. We just did a virtual key mapping. As soon as our program gets sent 3 characters, we just map it to 1. Pretty cool. Still, as an exercise, you now need to finish up arrow left, arrow right, page up, down, home and end, and then come back after a short while and compare what you have with the code that I'm just going to write just now. All right, we're back in our method, which I just finished up, and don't freak out. It looks a bit different to what we just had. I'm going to walk you through it slowly. We're still reading in the escape character. Did we just get an escape character? If not, well, return the key. Then, earlier we just checked for an open square bracket. Now we're checking for an open square bracket or an O. I'm going to tell you what that is in a second, but for now, let's just ignore it. Then we're reading in another key. And we say, well, if we just got an escape and an open square bracket, then let's do a switch. So I effectively turned our if and else into a switch. If there is an uppercase A, then you just got an arrow up key, B arrow down, C arrow right, D arrow left, home, and HF. Nothing too exciting. Then we had the problem with the 4 characters, because remember, page up was an escape character, square bracket, 5, and a tilde. So we have to read in yet another character if we got a 0 to 9 character. Ooh. And then we need to find out if there was in fact a tilde sign afterwards. And if there was a tilde sign afterwards, then we have to switch our key, in 3rd place here, find out what the number was. If it was a 1 or a 7, it's the home key. If it was a 3, it's the delete key. 4 and 8, it's an end key. 5, page up, 6, page down. Crazy, isn't it? Well, let's show you something else. The same thing goes if we don't get an open square bracket, but we get an O, right? For example, escape character, then an O and an uppercase H. That's also the home key and with the F and end key. Why is that? Because depending on the operating system you're using and the terminal you're using, it's not guaranteed that your home key comes in as escape character, open square brackets, then a 7 and a tilde. It could also come in as an escape character, uppercase O, uppercase H. That means you have to bang your head against the wall 5,000 times, find a list somewhere online, depending on with a nice little matrix, depending on what operating system you're using, terminal you're using, what escape sequences do these keys actually emit. Or you simply clone my code and we finally start moving the cursor around. Well, pooh, as we say in German, that was a long section on detecting key presses. Let's do something useful with that and finally move our cursor around. For that, what we need to do is we need to first of all remember the coordinates of our cursor. So what we're going to do is private static int cursor x equals 0 for now and cursor y also equals 0. Then I want to uncomment my refresh screen method again so that we can actually see our editor window. And when I scroll down even a bit more, we're going to spend the rest of the time now in the handle key method. I want to comment out, printing out the characters on the screen again. We're now in full-blown editor mode again. And what I want to do is, apart from handling the Q key, by the way, which will later on have to turn into Control Q because just pressing Q exiting the program doesn't make sense for us now. But what we want to do now is we want to say, well, if the key that the user pressed was either arrow up or arrow down or arrow left or arrow right. And by the way, maybe even home and end. Let's include them as well. If it was one of those keys, then we want to move the cursor. And I'm just going to create a new move cursor method here. And because I feel I'm in refactoring mood, I'm just going to say this is now Q means we exit the program. Either one of these keys, we just move the cursor around. What does moving the cursor around actually mean? Well, it's going to be a simple switch statement. So we're going to switch through our key, and we say in case the user pressed arrow up, for example, we need to do something. What do we need to do? Well, simple arithmetic. Hopefully I said that right. In case the user pressed arrow up, what should happen is that cursor Y decreases, right? Because we're going up towards 0. In case of arrow down, what happens is that cursor Y should actually increase. So cursor Y plus plus. Same with left, right, home and end and whatever. Now, what I want to do is I want to put in some boundaries straight away that the user cannot move the cursor off the screen effectively. So arrow up should only be pressable if cursor Y is greater than 0, right? Like so. And then the same thing is with arrow down, you should only be able to press it if cursor Y is less than rows, the amount of rows we have -1. Remember, we have 19 rows, for example. Cursor Y is 0 based, however, that's why we deduct -1. And then take some time, a couple of minutes, fill in the cases for left, right, home and end, and I'll see you back again here in a second. Okay, welcome back. There shouldn't be too many surprises because arrow left and arrow right work exactly the same way as arrow up and down, only that they modify cursor X, obviously, and instead of rows, use columns. And by the way, the home button, clicking the home button just puts, for now, cursor X to 0, end button puts cursor X to columns -1 for now at the end of the screen. All right, so we detect the key presses, we handle them, so we set the coordinates. So Marco, what actually moves our mouse cursor? And you will be surprised. What we need to do is we need to go back to our refresh screen method. Let me just actually find that right up here, refresh screen. Read key works, handle key works, refresh screen we have to update. In here, what we've seen so far is that this line, remember, clears the whole screen. This line moves our mouse cursor to the top left corner. Then we print whatever is on the screen. And at the end, we reposition our mouse cursor because it's now in the lower right corner. We position it in the top left corner again. What we actually want to do is that this here prints our mouse cursor in the right position now. The way we do that is very simple, because what we can do is we can format this string, change it a tiny bit, and put 2 numbers here, %d, %d. That's the Y coordinate, and that is the X coordinate of our cursor. So we're just going to do cursor Y and +1, because on the terminal, again, this is 1 based, actually not 0 based. So cursor Y +1, cursor X +1. And this should print our cursor in the right position after we press the key. Can you believe that? Well, let's try it out. I'm a bit scared. Let's try it. So here we're inside our editor. I'm pressing arrow down. Ooh, that works. Arrow right works. Arrow up works. Left works. Let's see if I can. No, I cannot move off the screen. Here at the top, I cannot move up. Let's see what happens down here, right? The status bar is here. We'll fix that later. And if I go to the right, that should also work. Yeah, it also works. Home key works. End key works. That means we're ready now for actually loading a file and displaying that here. Let's finally open up and display files. How to do that? Well, it's going to be rather simple. Let's imagine that we want the user to specify exactly 1 argument to our program if he wants us to open up a file for him. And then, well, the argument is going to be our file name, or the full path actually. And what we're going to do is we have to use Java's path API to open up the file. So I'm going to go file name. Right, we get the path object here. I could have also used the very old legacy file API, which I don't want to do. Use the path API for that. Now, we only want to do something if the path exists. So files exist path. And then we want to load the entire file into memory. It's an area we could optimize later on, not to load 10 megabytes of text files into memory. For now, it's going to make things simpler. So we're going to start off with that. There's a nice little method I can call files.lines, which will read in a file and give us a list of files back, actually, not just a list. In fact, it will give us a Java stream back, and I'm going to wrap that, I think, try with resources. So if there's any problems, that our file descriptor gets closed again. Now, I'm going to call stream to list because I want to have a list of strings. So exactly, my file should be turned into a simple list of strings. And I don't want to remember it here. I just want to go with a field up here, a global field. And we could make things simpler by just saying that if we don't read in a file, our content is just an empty list of strings. Having our file as a list of strings will make things very simple in a second, which you will see after we did some tiny refactoring. Because today I feel like in cleanup mode, so not open editor. This is going to be called open file. So we have a new method, open file, in the raw mode init editor. That's fine. And now we need to also catch an exception down here, which I forgot. And by the way, I don't want to print out the exception here if there was any problem reading the file. In fact, it's a to-do for later. We could display a nice little message in our status bar. Back in our refresh screen method, we need to change things up a little bit. This is where the magic happens. This is where we want to display the file. Remember, here we're deleting the whole screen. By the way, let me just comment that out for a second. I'll show you a nicer way of doing that instead of always deleting the whole screen. We position our cursor, not the mouse cursor, just the cursor in the upper left corner. And then we print out for now tilde characters for all the rows of my screen. Now, what we want to do is we only want to print out tilde characters if we don't have enough content in our file. So if the file is shorter than our rows effectively. The way to do that is with a tiny check. If we say I is greater than or equals to content size, then we print out tilde characters. Otherwise, what we're going to do is we don't print out tilde characters. We print out content get I, right? Like so. And then, by the way, we always print out the carriage return either way and the new line here. So like this. We're missing one tiny thing as we are not deleting the whole screen anymore. What we're now doing is position the cursor, write the character or write out the line. What we also want to do is we need to use another escape character here, which is open square bracket K, which deletes the rest of the line if there was anything already written on the line, and then the carriage return and the new line character. It's just a tiny optimization. And this bit should actually display our file. Let's try it out. As you can see, I'm now calling my program with the license file of the Gradle project. Let's open it up. And yes, we can see our file here. I mean, I cannot, scroll through it because we haven't implemented any scrolling. So only the first 25 whatever lines of the file get printed up, but that is pretty cool. Let's try it with a shorter file, the README file, I think. And as you can see, yes, that looks great as well, because here we have the text and the rest of the rows get filled in with a tilde character. That is pretty cool. So files are being displayed now. Now it's time to implement scrolling. Last but not least, the trickiest part of this entire video, making scrolling work. For that, first of all, let's clean up our code a tiny bit and introduce a couple of methods. So I'm gonna call this piece of code draw content because it draws our content. I'm gonna call this piece of code draw status message and then draw cursor, right? So no, I want to keep my original signature. I'm just going to go with that. And if you wanted to, you could also say that move cursor to top left, like so. Keep the original signature again. Now our refresh screen method looks like this. Second, I want to do a tiny bug fix because so far what we did is when we draw the content, we just go through rows -1 and print out everything. We did the -1 because we're printing our status bar later on after drawing the content. But in fact, what we also could do instead of doing it down here, we could do it up here. We could just initialize our editor with one less row. And then our mouse movement cannot go over the status bar again. Let's check that out. Did you just notice I said mouse cursor again? I just meant cursor. So rerun the program again. You can see everything still works as expected. And I cannot move my mouse down again over the status bar. And that's because we put the rows -1 into the init editor method. Now, to think about how to implement scrolling, let's change our status bar a tiny bit. Back in our code, I want to go to the draw status message method, which by the way should be called draw status bar. And I'm going to replace the status message with something else. I'm going to replace it by printing out the number of rows that we have, and also the cursor X and also the cursor Y position. And now let's rerun our program. As you can see, when I now open up our program again and scroll down a file, I can see in the status bar the number of rows I have, 22. I should have put a space here, the X cursor position and the Y cursor position 0 based, 21. And I cannot move down anymore, and that is because we put that limitation in. Remember 10 minutes ago, where we can only go down the screen, but actually we want to go down towards the end of a file. Let's change that. So back in our move cursor method, the only thing we need to change here in arrow down, we don't want cursor Y to be less than rows -1. We want cursor Y to be less than content.size, the size of our list. That's it. Let's try it out. Rerun the program, scroll down, and now, yes, you can see that we're actually able to scroll off the screen. The Y keeps increasing. I don't know how many lines that file now has. Hopefully, I'm going to reach the end of the file soon, so you can see that there actually is an end towards the file. Right, 420 is the end. And now I can scroll up again. That is one problem solved. The second problem is we don't yet know how to implement the scrolling. Well, let's approach it like this. Again, when I open up the file and scroll down, I'm here now, position cursor Y is 21. Starts at 0, now we're at 21. What happens if I press the arrow key down once more? Then now I'm on position 22. What I would like to see, ideally not, this row anymore, but the top row of the screen should now be the first row of the file. So there's an offset involved now. If I press down again once more, what happens is my cursor is now, cursor Y is 23. In fact, the top row of the screen should be the second row of the file, so +2 in this case. Again, when I press down one more, the offset should increase one more. So now this should be, in fact, the top line of the file, and the rest of the screen should be drawn accordingly. Which means we need an offset and we need to draw our screen keeping the offset in mind. Let's do that. Back in our code, let's scroll up again. And then we simply want to go, for now, we just want to go with vertical scrolling. So I'm going to have an offset Y equals 0 in here. And you can do the offset X later on yourself. Now, two things change. First of all, we have to kind of calculate the offset. Where are we on the screen? And that's what we're going to do in a second inside a scroll method. And by the way, I just put that scroll method in the wrong place. It should in fact go into our while loop. Before we refresh the screen, we should scroll to the right position, draw the entire screen, and then wait for the next key press. Now, think about what happens. We do the scrolling in a second, which means essentially calculating the offset. When we refresh the screen, we draw our content and we draw the cursor. Both of these methods need to change depending on the offset that is involved. Let's start with draw cursor because that's a bit simpler. At the moment, we're drawing the cursor at the cursor Y position +1. But in fact, now that could be 100, 500, it could go off the screen, which means we need to deduct our offset Y so that the cursor gets put into the right position. That's it. Up next, we need to fix our draw content method. At the moment, we simply go through all the rows of the screen, which is all good. And then we print out down here, we always print out from 0 to 21. In fact, what we want to do is we want to say that the file I equals our offset that we have yet to calculate plus the I. So let's do it like this. Man, that variable is a bit wrongly named, but so you understand what I'm talking about. We fixed draw content, we fixed draw cursor. Now the only problem that is left is calculating the offset. And by the way, this tiny method, which will have just a couple lines of code, is the trickiest method in the entire series, so to speak. And you can spend some time yourself, pausing the video, how you would implement that method, and then come back and see me, fill in the code for you. All right, let's do it. Imagine we're scrolling down, so cursor Y keeps increasing. If cursor y is greater than or equal to what exactly? Imagine our screen has 10 rows, where at the bottom we press the arrow down key twice, which means now that the offset should be 2 effectively, and the top line should be the second line in the file, right? And we should see the second line plus the 10 lines of the screen till the 12th line, which means cursor y, rather complicated, should be rows plus our currently already existing offset y, which is 0 at the moment when we open up the file, right? But it's going to increase. How is it going to increase? If the cursor is greater than rows offset y, then offset y equals cursor y minus the number of rows plus 1. I'm not going to spoil this line for you. What I want you to do is think about it hard for 10, 15 minutes. Actually, these 2 lines took me quite a while to understand. And it's just a nice little exercise for you to understand what is going on here. So let's do that. The second case is you want to scroll up again. Oh, whoops. The second case is much simpler. We want to scroll up again. So if cursor y is less than the current offset y, then we want to recalculate our offset y, and then it simply is cursor y. Again, you'll need to think about that. But what I want to do now is I want to show you if this is actually working. Ready, steady, go. So the file opens up. Let's go down till cursor y equals 21. Pressing down again, yeah, that looks pretty cool. Let's try and scroll up again. Yeah, that looks pretty cool as well. I can actually scroll up, I can scroll down, I can scroll all the way down. Isn't that pretty damn awesome? All right, let's wrap this up. All right, so the end is near. Let's recap what we did in this episode. We started with our skeleton viewer. It couldn't load files, so we implemented that, loading, displaying files, moving the cursor around, and also scrolling through files. There's a ton of stuff which isn't yet working. So the page up and page down keys aren't working yet. We don't have horizontal scrolling. We, by the way, cannot display tabs in the file, which is, by the way, super tricky. There's a ton of things, even with our cursor movements, which aren't working quite as they should. So in fact, let me know in the comments what you would like to see next in the next episode. Otherwise, I'm just going to continue with page up, page down, but maybe you want to see something else first or a different feature. Just let me know. As always, if you liked the episode, subscribe to the channel, click the button. And if you liked the episode, even if you didn't like the episode, let me know in the comments. Thank you. Sayonara.